So preparation of haloarenes. In preparation of haloarenes, the first is your direct, what you can say, halogenation. We can say halogenation reaction. So let me tell you from the beginning itself, we can prepare haloarenes, that is chlorination and bromination we can do. Now iodination is possible, but it is reversible. We have to use an oxidizing agent, and fluorination is not being done directly because you know it. The fluorine-chlorine bond, when it is going to rupture, it is nothing but it is an explosive reaction. So basically we can go for chlorination and bromination. So how we do that? Now here you will be taking, that is benzene plus, that is chlorine, in presence of, now this particular reaction, what I said you, it is an halogenation reaction. So it comes under what? Electrophilic substitution reaction. Remember that we have done it in class 11 in aromatics, that is in benzene properties, we have done this particular one. So benzene plus chlorine in presence of either Fe or FeCl3, we can say that, and in presence of dark, this reaction is carried out and at room temperature, at that is ordinary temperature. Alright, this reaction is carried out. So what we get it? We get it, that is a nuclear derivative. Nuclear means directly it is attached to the benzene. That is called nuclear derivatives. Alright, so we get chlorobenzene and HCl. So this is your, what you can say, halogenation reaction. It comes under electrophilic substitution reaction, where FeCl3 or Fe acts as an, what you can say, electrophilic reagent. It helps in the production of electrophile. Now how it is? FeCl3, when it reacts with Cl2, it forms FeCl4 minus plus Cl plus. It forms FeCl4 minus plus Cl plus. If I go in little bit details, more details, then it is in this way. Cl single bond Cl. Here a pair of electron comes here. We can say that. It is not a free radical reaction, because in case of free radical, remember it, the condition is not given here. That is, what is that condition is required? Either UV light or in presence of some peroxides or in presence of some chemicals. That is not given here. So what I have given, just to see it. So now here what is going to happen here, like Cl minus, so FeCl3 is a Lewis acid, remember it, it's a Lewis acid, FeCl3. Alright, so it takes a pair of electrons, that is it takes Cl minus to form FeCl4 minus. And here when it takes a pair of electron, it becomes an electrophile, that is positively charged Cl plus. Now if you ask me the mechanism in this is in this particular way. It is being done, we have done it in class 11. Once more I am saying you, this reacts with the electrophile. Now this pair of electron will go here and it is going to form, that is here H and here Cl. Alright, so now this pair of electron will come inside, and what you are going to get? You are going to get, that is nothing but, that is chlorobenzene, and H plus ion is released. This H plus ion reacts with FeCl4 minus to form FeCl3 and HCl. So this is the mechanism of the reaction which you have studied in class 11. Once more I told you. So by this way, instead of chlorine I can take bromine also, and I can get, what you can say, that is bromobenzene, I can get it here. Okay, but here you have to take it FeBr3. You can take FeCl3 also, no problem, but you will not get FeCl4 minus. In that case, if you are taking FeCl3, let us say if you are taking FeCl3, I prefer to take FeBr3, but if you say no, I will take FeCl3, then if you will be getting FeCl3 Br minus, you will be getting it. That's it, no problem. So what in this way, what you find is that this particular reaction is going to take place. This is called as an halogenation reaction. Now what I said you, chlorination, bromination can be done. Iodination, if at all you are doing it, then what is going to form? It is a reversible reaction. Why? Because in iodination, instead of HCl, HI will be formed, and you know HI is a strong reducing agent. It's a strong reducing agent, HI is. So it will make the reaction reversible. So if I want that the reaction should be irreversible, alright, if I want that the reaction should be irreversible, then I have to use here an oxidizing agent. Like I can use here HNO3 or HiO3 or HGO, anything, any oxidizing agent I can use it. It is going to. So this makes the reaction in the forward direction only. If I won't take this, it will become reversible. So here what is going to form? It is going to form iodobenzene and HI. Now HI, what is going to take place? Now HI, you know, nitric acid is an oxidizing agent. It will give you, that is nothing but nascent oxygen, nitric acid. It is going to form H2O and I2 is being released. That means HI is decomposed to iodine. Hence it does not get a chance to make the reaction reversible. We can say that. the reaction can be carried out in this way. From here we got this nascent oxide from HNO3. You can write here HNO3 also you can complete the product. In that case, if you are writing HNO3, then remember that what you are going to get it. That is, you are going to get water, iodine and nitrogen dioxide. That's it. Clear? So we are not interested with the secondary product. So hence I did not write it. So if I want that the reaction should be irreversible, then what I said you have to take an oxidizing agent. Any oxidizing agent you can take it and you can do it. But fluorination is not possible by this method. Fine. So this is your halogenation reaction. We can say that. Thank you very much.